We will give the introduction to forces and fields first before we start electrostatics. Okay? Or before we start the unit called electricity and magnetism. In that, I've given you 8 headings. The first heading was what? Electrostatics. But even that electrostatics, I'm not going to start the lesson immediately. I'll provide some important introduction to forces and fields, which is the defining heading for the whole unit called electricity and magnetism. Right? First, what is a field? Somebody has any idea? Please tell me. Red B. What's a field? Remember, field is something which explains why there's a force. Okay? Field concept or field explains why there's a force through space. Or rather, I'll say it explains action at a distance. Action at a distance. What do you mean by this, children? Like I've got Earth here and an apple falls towards it. We say simply gravitational force, we say. But why gravitational force is there, if somebody asks? Because there's no physical connection between this Earth and the apple. So this force is acting through space, empty space, it is acting. So to explain such forces acting through empty spaces, people introduced, like whom? Faraday, for example, Maxwell later. They introduced the idea of field, right? So what it says is, don't bother, even if there's no connection between the Earth and apple, Earth has a field around it. That field applies force on the apple was the idea. So field concept is there because we would like to explain why force is there. Force, of course, is a push or pull, we know. But why this push and pull are happening? What we see with our eyes is that there are pushes and pulls. Even though apple is somewhere there, even though I don't see any physical connection between the two, the earth is still attracting it. So people told, don't worry. There is a real thing. Don't say it is in our assumption. Field is real. Believe me, Guru Charan. Okay. So this field is there and this field is applying force, we say. So why field now? We said, what's the field means what? The field idea, field concept, or field is, of course, we'll define mathematical way, but field explains why there is a force through space. It explains action at a distance. Do you follow action at a distance, children? The word? Your names are not familiar to me to call you by names, but Guru Charan is there on the screen. Or Rebecca, Rose. Action at a distance. Do you understand? Force through empty space. That's what you mean by action between two objects, though there is no physical connection between them. So that's where we have the field idea. Of course, if you want to say where is field means, you'll say in a region of space, if a particle experiences a force which follows some inverse square law, for example, in that region, you'll say there is a field. So what is a field means, what will you write? If in a region of space, if in a region of space, a particle means this is a test particle, children. A particle experiences force. Test particle means we brought something from somewhere. Like this is a region of space. This apple is the test body here. Test body, a test particle. If in a region of space, a particle experiences a force at every point, which changes according to some law. then the region is said to be having a field. The region is said to be having a field. That's what I meant by saying that field concept justifies the force. Any question, children, here? And why they say it changes. If it is not changing, field idea may not be important for us. The force keeps changing as you keep moving the apple from a point near to the surface of the earth to a point away from the surface of the earth. We see that force is falling with 1 by r square. So this kind of fields are very, very important for our discussion. All right. Yes, but what is electric field? What is magnetic field? All that is going to be important. I'll just change the screen, children. You need to tell me if I'm changing the screen, and if you want to write anything there, if you want to ask anything there, you stop me. Okay. Any questions, children? Let me see. Anshuman, 5D, 7CC, B, 5A. We expect you to come with your names. All right. Your names have to be there. Vijay, Sushma, Paddepalli, Srihit. Okay, Rishita. So can I change the screen, children?
Yes.
Okay.
Yes, sir.
Yeah. Now, look, what kind of fields? Yes, Sai Kiran. What kind of fields we have? What are some examples of fields? One, electric field. Two, gravitational field. Three, magnetic field. Actually, we should call it electromagnetic field, but deliberately I put it electric field separate and magnetic field separate, because that's how historically people discovered these electric and magnetic fields. See, actually, if you have any idea, I mean, if you have any doubt, what is this field business? There's no field, it's only we are imagining. Just think of this case. You'll know really the fields are going to be there. A north pole, south pole for a magnet you take, and fix one magnet here, fix here, and keep taking this towards it. You actually, your hand feels some kind of some opposition in the space. Did you ever see that? Or if you leave this magnet like this, free, as you keep taking this magnet towards it, of course, between the surface and the magnet, think that there's no friction or make it smooth. This magnet moves, right, without this touching it. That means in this space, there is really a field. Try to understand. So field is not what we call just our figment of imagination. It is real. But how do you define it mathematically? All that will slowly do. So magnetic field, and then elastic force field. I say. There's no special name for this. Elastic force field means it explains why the spring force is there. Okay. And what else you have? Gravitational field is over, electric field is over, magnetic field is over. Yeah, these are some important fields. And the other fields, they don't have special names, so we need not bother. We'll define fields later in terms of the laws they follow. Inverse square field, 1 by r field, 1 by r cube field. See, all that chemistry forces, you give them different names. Van der Waals force, and I don't remember what are those names. So many names you give for them. All those fields are basically electric and magnetic fields. All right, some examples. But source of, from now onwards, remember source and test. I'll define few things in the beginning itself for clarity's sake in future. Source of gravitational field is mass. That means if I have a mass here, around it there is gravitational field. This is the source mass, I'll say. Into this field, I bring another mass, which I call as test mass. The source mass applies force on this. But remember, even this has got a field around it. If I bring this mass here, this is experiencing force because of this. In that case, this becomes a source mass, this becomes a test mass. Source mass, do you understand the meaning of it? The source one is the one which is producing field around it. The test mass is the one which we use to test whether the field or not. See, if I don't bring a test mass, I won't be knowing whether the field or not. Field will be real. It is there whether you bring the test mass or not. But only if I bring a test mass, I'll know that there's a force. So the one we bring from somewhere and place in a region to test whether there's a field or not is the test mass. The one causing that force is the source mass. But source of electric field is charge. Source of electric field and magnetic field both are electric charges. But remember, electric charge and mass you cannot separate. If I take a copper sphere like this, it has got a mass, agreed. So it's got a gravitational field around it. But if I rub it, I'll create excess charge on it. Before rubbing or before removing electrons from it, it had equal number of electrons in the orbits and equal number of protons in the nuclei. So there's no net charge there. But once I remove few electrons, this also gets charged, for example. Now, around this mass, which has got some excessive charge, there is electric field like this, repulsive electric field if it is a plus charge, and there is an attractive gravitational field like that. This is electric field. So charges produce electric field, masses produce gravitational fields. But charge and mass are always together. Matter has got two properties. One is mass, the other is charge. Mass causes gravitational field, charge causes electric field. Right? I'll continue, children. But anytime you can raise your hand and ask a question. Pranav? Which Pranav is this? Okay. Gurucharan, any question, child?
Yes, sir.
Tell me.
Sir, does this electric field affects the gravitational field or not?
No, it won't. Electric field and gravitational will be existing independently of each other. They don't affect each other. Yeah, that's a good question because when you solve problems, that will be real trouble, Gurucharan. Yeah.
Okay, sir.
Yeah. And then I'll go. Can I remove? Can I change the screen, children? I want
sir.
your feedback. I want you to understand things. The whole lesson will be done extensively. Believe me. Okay. Then I'll change the screen. Look, 4 statements I'll mention. I want you to respond to these statements in a big way. 4 important statements. Very, very important statements. 1. Of course, gravitational field we don't talk here because that is over in first year. Right? But we'll talk about electric and magnetic fields today, right? So look at this. First statement. Electric fields are produced by, please write it also. Electric fields, EF stands for electric fields, are produced by both stationary and moving charges. Electric fields are produced by both stationary and moving charges. 2. Electric fields exert force on electric fields exert force on both stationary and moving charges. And then 3. Magnetic fields are produced only by moving charges. And 4th statement, magnetic fields apply force on moving charges only. So here is the whole summary of the total unit called electricity and magnetism. Children, electric fields are produced by both stationary and moving charges. Electric field exert force on both stationary and moving charges. Remember, the whole of electricity and magnetism is only about forces and fields. Of course, potential energy comes, but fields have got energies there. Force, field, and energy, I can say, if you want. The whole lesson is that. That way, physics is beautiful. Such a great unification of ideas will be possible. You do not have to blindly remember the information there. But now I want you people to respond to the statements. Or because now I'll keep asking you questions. If, depending on your response, I can go on elaborating it. And remember, in fact, I'll be giving you exam questions now. Though I don't call them as exam questions as I keep talking. In fact, they are all the exam questions which keep coming later.
How is that magnetic field only applies to moving charges? Like if you have a stationary iron or something that is attracted by a magnetic field, right, sir?
Yeah, good question, Ramya. What she says is, if there is an iron piece, that will be attracted by a magnet, no? So where are moving charges, she is saying, isn't it so? Children, like that, I want few more questions. Ramya's question, remember, Ramya Manasa is asking the question, sir, if you got an iron piece like this, and if I bring a magnet like this, this is attracted. So where are moving charges here? And how do you say that magnetic fields apply force only on moving charges when there are no moving charges, she is saying. All right? Isn't it, Ramya?
Yes, sir.
Yeah. Remember that question, everybody. I'll come back to that. And then, any other question, children? You have to speak. I told you already. You may not have started your lesson at all like this, isn't it? I'm telling you, in the first class, I am giving you the summary of the whole unit, not just one lesson. Other children, please. Ramya asked a very decent question. Yes. Okay. First, I'll just tell you an experimental way to understand these things, and then I'll give you questions regarding this. Did you all write the 4 statements, children?
Yes, sir.
Okay, I'll continue.
Yes, sir.
Yeah. Look, I'll just give you a few examples, after which I'll make you believe that this is correct, and then give you a few questions. We know very well what is this?
Comb.
Yes. You comb your dry hair with this, comb, and take it near pieces of paper. What did you observe?
They get attracted to the comb.
They're attracted.
They stick to the comb.
Yeah. Right? So here, when you rubbed your dry hair with this, you create charges on the comb's bristles. They create electric field around them, and they in turn create dipoles here. Actually, they create induced charges, let me say, and the force acts. This is what you call electric field. The comb now developed what field? Electric field. This electric field is applying force on the charges inside the paper pieces. Paper pieces are called insulators, children. So in that they create a minus plus like that, and they provide a force and torque. This is an exam question which I'll elaborate it later slowly. But here, this is the best example for you to feel about an electric field. Or you take a sphere, metal sphere, and rub it. You remove electrons from, for example, from it. You remove electrons from it, it allegedly gets positive charges. Now in this, you bring one more electron or something like that, you'll see that to be moving like this. Or you may say, sir, how can I bring an electron? Take one more sphere and rub it once again and remove electrons and put them on a free, smooth table. You'll see them to be moving away from each other. This is another example where we say electric fields are produced. If you have got a wire, a wire in which current is flowing, put a magnetic needle near it, it gets deflected. Did you all remember these things from 10th class? Oh,
Yes, sir.
Yes, sir.
don't write here, children. I disabled the annotation, right? I forgot it, right? Now, this you also, if a current is going through a wire and if you bring one magnetic compass, that gets deflected, right? This is an example where moving charges form magnetic field. Here, electrons are moving inside. So they form a magnetic field here, and that magnetic field will be deflecting the magnetic needle here. But you also must have learned somewhere in a discharge tube where electrons are produced, cathode ray tube. If cathode rays, an electron stream is going like this, if I apply a magnetic field by a Harshov magnet like that, you've seen that electron beam bending like this. This is where we tell that magnetic field apply force on moving charges. But in case, if I have a bar magnet like this, a Harshov magnet like this, for example, and if I place this positively charged sphere here at rest, nothing is going to happen to it. See the possibility of this, because these are all real examples. I went a little fast, but I hope you followed it. If I have a current going wire like
Sir,
this,
can you repeat it, sir?
yeah, I'm telling you now. If I've got a current going wire like this, and if I place a magnetic needle, it is getting deflected. But if I take the same magnetic needle here, will it get deflected? Tell me. Rebecca, if I have a charged sphere like this, from which I remove some electrons and place it on a table, if I bring a magnetic needle, it's not going to deflect, because this forms what you call electric field, and it is not going to apply force on this magnetic compass, which is a magnetic dipole. In a similar way, if I bring this charged sphere here and placed it between north and south of a Harshov magnet, nothing is going to happen. But if I put a Harshov magnet over this cathode ray beam, the beam gets deflected. So what is that I'm trying to tell you here? Just from experiment. This is how electricity magnetism was discovered. I'm going that way. If you respond, of course, I can talk any amount of the subject. Srihit, tell me whatever I spoke.
Sir?
Yeah, here, what is this experiment for? Magnetic fields cannot apply.
On positive charged bodies.
Cannot apply force on. Tell me.
Stationary charges.
Stationary charge.
Stationary.
And here, what is this example for?
Magnetic force is applicable on moving
magnetic field, children. Magnetic
field.
Field applies force on what?
Moving charges.
Moving charges.
Right. This is an example of that. And this one is the example of what? Electric fields are produced by stationary charges. They apply force on stationary charges. Similarly, this one also. Electric fields apply force on. Electric fields are produced by stationary charges and they apply force on stationary charges. So just for a while, before understanding what is magnetic field, what is electric field in more deeper way, Remember these four axioms. But anyway, I'll address one question because people will be worried if I don't do that. Like somebody was asking a question, Rami, I think. If I bring a magnet near an iron piece, getting attracted, sir, how is it happening? First of all, remember, Ramya, Guruchan, I'll come back to you. This magnetic, in a bar magnet also, the magnetic fields are formed by circulating electrons, child. So magnetic fields are formed by only moving charges, believe me. The magnet, whatever field you say magnetism is because of what? Unpaired electrons moving in the outermost orbits. They form the magnetic. Okay. Soumya. So not Soumya, Ramya.
Yes, sir.
So first of all, remember the magnetic fields are formed by moving charges even in a bar magnet, though we don't see it with our naked eye. And then this magnetic field will apply force once again on the moving charges inside the iron piece. We are talking at a particle level. We are not talking at a bulk level. Try to understand. Bulk level, you won't be seeing the particles. But the ultimate reason that at a microscopic level, if you speak, that's what we are saying. Magnetic fields are formed by moving charges. They apply force on the moving charges in the iron piece among. And that's why they create dipoles and they put it towards it. All this I'll be talking in a more mathematical way as we keep progressing in the lesson. But as ideas, they should settle. As ideas, they must settle first. So, Ramya Manasa, just please, for my satisfaction, repeat the four statements I made, Amma. We'll apply them few cases and then come back to more deeper one. Ramya.
The first one is electric fields are only produced by
Not only, Amma. Electric fields are produced by all.
Stationary and moving charges.
Right.
An electric field exert force on both stationary and moving charges.
Correct.
Magnetic field are produced only by moving charges.
Correct.
And magnetic field only applies on moving charges.
Force on moving charges. Right. Now take these things as statements which are derived from experiment like this. Then answer few questions. Then you'll feel great about yourself. Right? I'll keep giving you many examples here, children. Keep writing along with me, keep talking to me, keep answering the questions. The first is, but remember, children, you will not ask me a question. Rest and motion, aren't they relative terms? Aren't they relative terms?
Yes, sir.
So,
Yes, sir.
what do you mean by rest and motion, you should have asked? So, I'll add one statement for the first one. In the laboratory frame, these statements are valid. These statements are valid. That means when I say rest, what do I mean by that? I'm standing on the ground. Ground is supposed to be at rest. It's not an accelerating frame, let us imagine. Or I'm standing near the table like this. On the table, I've got all my equipment which I discussed until now. When I said these spheres are charged, I mean to say they are placed on the table. And I'm watching from here. Then I'll say this has got only electric field. In a similar way, on the lab table, I'm doing this experiment and standing here. For me, electrons are moving inside. They form electric fields, magnetic fields, I'll say. Once again, I'm standing in a laboratory and saying that, yes, these electrons are moving. See, if I stood on the electron won't be moving, right? I don't want to change the reference range like that. I just want to sit on the lab chair and watch this experiment happening. Electron beam was going straight like this, but I put one harsher magnet over it. This electron beam got deflected. That's because of the magnetic field force I was thinking. In a similar way, even here, I'm standing in a laboratory frame. Lab frame is ground frame, which people talk. At this 11th and 12th level, teachers are used to talk ground frame, but it is actually a laboratory frame fixed to the ground, you should say. What is it? A laboratory frame fixed to the ground. So the statements are valid like that. Otherwise, stationary and motion have no meaning, absolute meaning, right? So keeping that in mind, I'll put you many questions and I want you to answer. And I told you to be positive. If it's going wrong, don't worry about it. There are 2 electrons at rest in the lab. 1 electron, another electron at rest. This is at rest, this is also at rest. That means you are standing here in the lab and somehow seeing 2 electrons to be at rest. My question is, what field do they form? What field do they form? What force do they exert on each other? What force?
Electric force, sir.
Just a minute, children. Do they exert on each of them? Please write. Anyway, I'll put the video also on the YouTube for private use. You can keep watching it again. But in the beginning, when you write, that will be nice. So, who is that Guru Charan? Tell me.
Electric force, sir.
Yeah. First, talk about field, child. Both the electrons have got. Both the electrons have got. Both the electrons have got what? Electric fields around them. Okay. Each electron applies what? Electric force on the other. So this is our statement. Please write. And second one. Remember, all this is mathematics. Finally, we'll convert into. We are standing in the laboratory frame. 1 electron is at rest, children. This is at rest. This fellow says the electron is not moving, but the other electron is moving. So now answer the same question. What field do they form? What force do they exert on each other? Ramya, what is her name? Ramya? Yes. Yeah, Ramya Manas. Tell me, Amma.
Electric field and
No, more details. Like I told you, both electrons have got electric field around them. Each electron applies electric force on the other. So that kind of a statement you should make now. Come on.
so electric field is produced and moving.
So the 4 statements. I made you read the 4 statements, Kadama. Ramya.
Yes, sir.
Remember those statements and answer it.
Both electrons have electric field around them.
Yeah.
And the moving electron is applying force on the resting electron.
Yes, more clarity I want. Anybody else? Devachit Praharsha, tell me.
The both, according to the statements, they may have electric field or electric field they have, sir.
I'll say this electron is A, this electron is B, for example. A and B both have got electric field around them.
Electric field. Yes, sir. Electric field.
What is the statement based on which you're saying this? We're told electric fields are formed both by stationary and moving charges. So this electron is stationary, it has got electric field. Though this electron is in motion, even that has got electric field. But B has only magnetic field around it. Sorry. B has also a magnetic field around it. And A has no magnetic field around it. That means B electron B has both electric and magnetic fields. A has only electric field. Now, what kind of a force they apply, both exert on each other, electric force only. Look, this has got electric field. This has got electric and magnetic field. But this has no magnetic field. So magnetic field and magnetic field interact, electric field and electric field interact. So though this has got magnetic field around it, since this electron is not moving, it cannot experience a force because of the magnetic field of B. But this electron can experience electric force of this because even this has got electric field around it. That's the logic. Devarchit Praharsha, Manasa Ramya, and Anshuman, and what all the names I don't remember, but I want now your feedback.
Yes, sir, understood.
You understood. And others?
I too understood, sir.
Clear, sir.
Srihit also says he understood. Please write it down. And slowly start speaking, children. A and B both electric field. A and B both have. Here I missed out have electric field around them. B has also a magnetic field around it. Look, why this electron A is not experiencing a magnetic force, children? Because it's at rest and it doesn't have a magnetic field around it. One simple technique I'll tell you. Electric field and electric field interact. Magnetic field and magnetic field interact. That's the main idea. So electric field is there around A, electric field is there around B, so they exert electric force on each other. This has no magnetic field. This is not moving. Though there's a magnetic field around it, this magnetic field cannot apply force on the stationary charge. That's the main idea. All right? Anshuman? Yes?
Yes, sir.
Okay then. I hope you all followed it because my future lesson depends upon what I do in the beginning. I define everything for you. You do not have to bother. Even if you don't read a textbook, I don't care. If you read, that's well and good, but this is more than a textbook. The summary of some thousands of textbooks and 30 years of experience. Okay? Right. Can I move ahead, children?
Yes, sir.
Okay then.
Yes, sir.
Right. Third exam. Now, once again, I have to start looking from standing on the ground here. Two electrons are there. Both are moving. Now tell me. With the same speed for a while.
They both
So both
Sir.
the electrons have
Electric and magnetic fields.
That's good.
Both.
Also, they have magnetic
So
field.
now you understood the trick, right?
Yes, sir.
So we'll write that. Both the electrons have electric and what? Magnetic fields around them. Right? Now about forces, children, come on. Ramya, you are in intermediate second year or 12th, Amma? Ramya,
Second year, sir.
second year. Where?
UG.
Which branch of UG?
Miyapur.
Miyapur, okay. Oh, there's a branch there also.
Yes, sir. It's like a sub branch.
Okay. And which school were you previously before coming to Fuji?
Time.
Which one?
Time school, sir.
Time school. Okay. All right. Now tell me, Amma, this one, second. What
So
kind
they-
of force?
They exert both electric and magnetic field on each other.
Electric and magnetic fields are there. Electric and magnetic forces will be there.
Yeah, forces, yes.
And Anil, I'll tell you, children, this because of the electric field, they repel. This electron is pushed away with F. This electron is pushed away with F. And funnily, because of the magnetic force, they attract Amma. That will slowly know later.
So they don't move because both.
They move as a result of these two forces. But remember, this magnetic force is very less compared to the repulsive electric force. This magnetic force, attractive force, I told you, no? Harry, don't you know, you must have seen somewhere, if there are two wires, current carrying two wires in the same direction, they attract both. Somewhere you don't, probably, I don't know. So this is something like two electrons moving the same direction is having currents in the same direction because the magnetic force they'll attract. I'll show you that. But just make a note of it now. Amma, it's not the question of not moving because this electric force is very, very high compared to this what? Magnetic repulsion. We'll calculate and show you how they are. I mean, what kind of difference is there between the magnitudes of electric and magnetic forces. So, what should I write here, Ramya?
They exit both
The
electric and
experience.
magnetic
The experience here. What did I say?
experience.
They experience both electric and magnetic force. All right. Now let me see.
Sir,
Yes, Guru Charan.
sir, why don't they repel due to magnetic field?
Why do they attract? You should ask, right? Huh?
Yes, sir. Means, yes, sir.
We'll show that. Just I'm giving you some introduction. No? Supposing electrons are moving in opposite direction, they repel. Guru Charan.
Okay, sir.
We'll come back to that. Remember all these things. Everything is mathematics. Everything is ultimately defined in a proper way. Huh?
Okay.
Sir,
Yeah.
sir,
Yes.
how do both electrons attract, sir? Means both are negative only, no, sir.
Yeah. Who is this actually? Deva. Who is this asking?
Sir, Devachit, sir.
What you thought was only electric force, Devachit. You did not know about magnetic force. What you thought previously, because electrons are there, repel is because of electric field and electric force. It's not magnetic. Now you should learn something more new, right? Huh?
Yes, sir.
Right. Now I'll ask you some nice question. Once again, stand here in the lab. I've got one current carrying wire and one electron at rest. If you answer this properly, I'll give you 50 rupees. Come on. This is a current carrying wire. Probably you connected one battery to it if you want it. Okay? You can show if you want. Sir, how is the current going? You don't worry. This is plus, this is minus. So Rishita raised her hand. Come on, tell me, Rishita.
So the current carrying wire has electric field and magnetic field around it, while the electron has only electric field.
So tell me. That's not correct, Amma.
Sir,
But
I think
continue.
the electron revolves around the wire, sir.
Snehit. Anybody else? A surprise is waiting for you here. Look, do not bother. Say, do not bother. Just can you use my 4 axioms I mentioned? Let us think they're axioms only for a while. See, the whole IIT business is that, children. Not that all the students who are top rankers know the meaning of everything, but their axiomatic approach is great. The axioms are true, whatever reason we don't know. So how to apply them is the main point here now. Come on.
So both magnetic field and electric field is produced by the wire.
No, child. Remember, there's only magnetic field around current carrying wire. Why you know?
It's a moving.
Moving electrons. But
Yes.
remember, that wire has got equal number of. The net charge in the wire is 0, Amma. Ramya. This could be a question in BitSat, for example. I told you, BitSat, all these things are conceptually strong, not that the questions will be tough or lengthy. Ramya,
Yes, sir.
this wire has got no excess charge, right?
Yes, sir.
So the electric field of electrons, though they are moving, and the electric field of protons inside is cancelling out. Emma?
Yes, sir. Understood.
So now tell me about the fields.
So magnetic field is produced by the wire, and
Magnetic field is there around wire. There around the wire. Right?
Yes, sir.
And
An
electric field is
around
only electric field is there around electron.
electron.
Electron. And about the force, children, no interaction. Why? This wire cannot apply force on stationary electron because it has got only magnetic field. Magnetic fields do not apply force on stationary charges. And this electron cannot apply net force on the wire because electric field is zero. No net charge on the wire.
Yes.
In other words, there's a magnetic field here, there's an electric field here. So the magnetic field and electric field do not interact. That's what the whole idea is. So no force at all. No interaction means no force on anything. Tell me now. Children?
Yes, sir.
Okay. Today in the beginning, of course, we spoke so much, so we took time. No problem, actually. This will continue tomorrow. There are more examples. But today's, what you remember from today's lesson is this, the 4 statements. You can come prepared to trouble me tomorrow in the class. And did you all understand the things, children?
Yes, sir.
If you did not follow anything, please tell me. Was it interesting? Was it looking fundamental?
Yes, sir.
Yes, that's what you require. And if you're ready to speak, I can make it very, very good for you. Okay. All right. Thank you so much. For the present, I'll end the session. And tomorrow, once again, at 9 o'clock, we'll meet. And if you like the lesson, of course, you can tell your friend that Srikanth sir is teaching online. All right. And that looked interesting. Let us go. You can tell them and ask them to register tomorrow. And you all also know that Deepthi has spoken to you. There's a referral bonus as well. All right. So if they come later, probably people will come later. I know as exams approach, they get tensed up and come. Better come now because there's still a lot of time. We can do subject in a very nice way, in a very cool way, if not very slow. We can take our time and try to understand things, talk to each other and develop the applications. Lot of work we can do. But whoever would like to join, let them join as soon as possible. All right. Thank you so much. I'll be ending the session for now and then stop the share and end the Zoom session. Thank you, children. Good night.